Hello everyone, I am Dr. Sirajul Faizi. I welcome you in my YouTube channel. Today in this video, we are going to learn about general method of structure elucidations of terpenoids. So I have already uploaded 4 videos on terpenoids. I would like to suggest, please go through my previous video. It will be more beneficial for you. So let us start our next lectures and today lectures on IR spectroscopy. IR spectroscopy is useful in detecting functional groups. You have learned in previous classes the theory of IR spectroscopy. So you know it gives the information about functional groups such as hydroxyl groups and oxo groups, isopropyl groups. Cis and trans also have characteristic absorption peak in IR region. These are the photo and picture of IR machine, IR spectrophotometer. Now friend, nuclear magnetic resonance spectroscopy, NMR, is also useful in elucidation of structures of terpenoids. This technique is useful to detect the identify double bonds, to determine the nature of end group and also the number of ring present, and also to reveal the orientation of methyl group in the relative positions of double bonds. And my friend, mass spectroscopy also very important tools to find out the structures. It is also very helpful. It is now being widely used as a means of elucidating a structure of terpenoids, used for determining molecular weight, molecular formula, nature of functional group present, and relative position of double bonds. And the most important technique, X-ray analysis. This is very helpful technique for elucidating a structure and a stereochemistry of terpenoids. So these are some methods for the structure elucidations of terpenoids. Now friends, synthesis. Proposed structure is finally confirmed by synthesis. In terpenoid chemistry, many of the syntheses are ambiguous, and in such cases, analytical evidence are used in conjunctions with the synthesis. So I will start with one specific compound, camphor. You know camphor properties and uses I will discuss, and then structure elucidation and synthesis of camphor. You can see this is the camphor. This is the camphor tree. Now camphor properties. Camphor occurs in camphor tree of Formosa in Japan. It is optically active. The positive and negative form occurs in nature. It is solid, having melting point 175 degrees Celsius. It is obtained by steam distillation of wood, leaves or bark of camphor tree. It sublimates at room temperature. So the uses of camphor, it is used in pharmaceutical preparation because of its analgesic nature, stimulant for heart muscles, expectorants and antiseptic properties. It is used in manufacture of celluloids, smokeless powder and explosives. My friend, it is also used as a moth repellent, moth repellent. So you can see different structure of camphor. So we will learn structure elucidation of camphor. So first, molecular formula. Molecular formula is C10H16O, found by molecular weight determinations method, mass spectrometry. Now, structure nature. Formation of monosubstituted product in the reaction monobromo, monochloro, camphor, and molecular refraction show that it is saturated. Now, the nature of oxygen atom presence. Nature of oxygen atom in camphor is ketone form. It is formed by the formations of oxime. Phenyl hydrogens with hydroxylamine give phenyl hydrazine respectively. You can see hydroxylamine give oxime and phenyl hydrazine give the phenyl hydrazone. Camphor oxidized with nitric acid yield a dicarboxylic acid called camphoric acid. Molecular formula C10H16O4 without loss of carbon atom. Further oxidations gives camphoronic acid C9H14O6. Camphor reduces with sodium amalgam. It gives secondary alcohol phenol. It confirmed that the oxygen in the camphor is cyclic ketone. Now, presence of bicyclic system. How you perform? The parent compound of camphor having molecular formula and corresponding C10H8. Molecular formula of saturated hydrocarbon of camphor C10H16O corresponding to the general formula of bicyclic compound CnH2n-2. So it is bicyclic system. Now, presence of a 6-member ring. When distilled with zinc chloride or a phosphorus peroxide, it yields paracymene. Formation of p-cymene confirm the presence of 6-member ring. Now friend, nature of carbon frame. Camphor react with nitric acid, give camphoric acid, and then further oxidation give camphoronic acid. Camphoric acid is saturated dicarboxylic acid with the same number of carbon atom as camphor. It suggests that keto group is present in one of the ring and the ring contains keto group is opened in the formation of camphoric acid. Now, nature of carbon frame. Thus, camphoric acid should be a monocyclic compound and camphoronic acid is tricarboxylic acid. In order to determine the structure of camphor, the structure of camphoric acid and camphoronic acid should be known. Now friends, structure of camphoronic acid C9H14O6. Camphoronic acid is tricarboxylic acid. Camphoronic acid undergoes distillation at atmospheric pressure. It gives isobutyric acid, trimethyl succinic acid and carbon dioxide and carbon. But it does not undergo decarboxylations under ordinary condition. It shows that 3 carboxylic acid or 3 carboxylic group are attached to the different carbon atoms. So, camphoronic acid is a alpha beta trimethyl tricarboxylic acid. You can see the camphoronic acid give the isobutyric acid and camphoronic acid give this product. So, camphoric acid is saturated dicarboxylic acid. Structure of camphoric acid you have to confirm. The saturated hydrocarbons of this C5H10 corresponding to the general formula CnH2n. Thus, camphoric acid is cyclopentene derivative. An oxidation of camphoric acid to camphoronic acid may be written as. So, you can see the structure. So, structure of camphoric acid. So, the camphoric acid contains above a skeleton 1 carbon atom, 2 COOH groups. So, the camphoric anhydride give that only 1 bromo derivative. It shows that 1 alpha hydrogen is present. So, carbon 1 is COOH group. The cyclopentane ring open on oxidation. It open with loss of 1 carbon atom to give camphoronic acid. So, you can see the structure of camphoronic acid and structure of camphoric acid. Now friend, structure of camphoric acid. So, undergo that 2 COOH group of camphoric acid produced from the CH2CO group in camphor. From this, the camphor contains a 6-member ring with J dimethyl groups. You can see CH2CO gives 2COOH on oxidation. So structure of camphor is like that. Camphor, it gave camphoronic acid. You can see J alkyl group is present, and this is the structure of camphoronic acid. So the structure of camphor, 1 and 2. The structure 2 is rejected due to on distillation with iodine it give carboxyl. It only possible for structure 1. So camphor on distillation give carboxyl and distillation no carboxyl. So the structure of camphor is this. So I will discuss in our next video synthesis of camphor. So if you like this video, then subscribe my channel, and thanks for watching.